students, welcome to Year 9 Science and Unit 2, Our Amazing Earth. This is video number 10 and we're going to look at the three different types of plate boundaries. Now while we do this, it's probably useful for you to perhaps split this video up. I was originally going to put this together as three separate ones, but probably it will be one long video with each of the different types of boundaries looked at in a little bit of detail, just so you have an understanding of each. We will go into them obviously in more detail during class. What we need to do is to compare and contrast the three types of plate boundaries. Now whenever you see words like compare and contrast, think about tabulating. When you put things in a table, it makes it very easy to compare them in terms of what is similar and what is different, and it also makes it easier to remember those differences when you have to recall them at a later stage. But we're going to focus in this particular video on these three different types of plate boundaries. So the first thing we need to do is talk about what those three different types of plate boundaries are. The first one are called divergent boundaries. These are also called constructive plate boundaries. They're where two plates move apart from one another. If they diverge, they're going apart. The way that this happens is what we've seen happening at mid-ocean ridges, is material is coming from the lower part of the mantle up through the lithosphere and out to create new crust. When this happens, what it does is it pushes two plates apart from one another. So the construction of the Atlantic Ocean at the mid-ocean ridge is one example of a divergent or a constructive boundary. And it's constructive because it is creating new crust. It probably follows and makes sense if we talk about convergent boundaries that these would be destructive. So if they are converging, then they are coming together. When this happens, then we get two main things, two main types of responses, and again we'll go into these in a little bit of detail later on. But either one of these will flow over or under the other one, or they will crumple into each other and create fold mountains. So depending on whether the types of crust that are hitting each other are both the same, both oceanic, both continental, or whether you have one oceanic and one continental, is going to determine exactly what sort of destructive event is going to happen at this type of plate boundary. The third type of plate boundary is a conservative boundary, or one that involves transform faults. Now what happens here is the plates don't either come together or move apart, but they just move side by side. Now sometimes it's possible for them to both move in the same direction but at different speeds. That can also create a conservative boundary, but more often we see that two plates that are moving in opposite directions to one another, not towards or away, but just past one another, create areas of instability, and you get faulting happening as a result of the rocks sort of slipping past one another. A really good example of this is San Andreas in California. And that's where we have a conservative boundary and where we find a transform fault. So each of these has been sort of very briefly represented diagrammatically on this slide. You can see where two plates are moving apart from one another, as they are here. This is divergent. When they're coming together, it's convergent, and when they're going past one another, then it's conservative. So that's the three different types of boundaries. Let's look at each one in a little more detail. So diverging boundaries. At diverging boundaries, the plates move apart from one another. Molten material from the mantle forces its way up, and what happens is that we get the formation of volcanic chains. Often we get volcanic arcs associated with these. We will, when we look at volcanoes, have a look at the different types of volcanic related structures that can form as a result of tectonic activity, because not all volcanoes can be traced directly to plate boundaries, but certainly a proportion of them can, and we'll look at the distribution of those a little bit later. What we get is a rift or crack forming between the plates, and we've also talked in previous videos about rift valleys, which are where two plates diverging from one another just start to create that little space of land in between them, that extra crust that's starting to form just in between those two plates. The magma from the mantle continues to rise up, emerge as lava, and form new crust. And so that's why we call these constructive boundaries, because we have the creation of new crust. A couple of different types of divergent boundaries where we have oceanic crust being created at a mid-ocean ridge. We have these little rift valleys occurring in between these two continental margins, for example, and they can be pushing those two continents aside like we have in the Atlantic, and we've talked already on these videos fairly extensively about South America and Africa. We also talked about Africa and Arabia. And when we talked about those two, we talked about the fact that there's a rift valley that's forming there, the Red Sea, filling that little gap in between those two continental blocks. And that's the sort of phenomenon that we find happening where we're getting divergent plate boundaries occurring between two regions of continental crust, with new continental crust being created. You can see in the diagram we have favoured the convection current model of motion of the plates, and you can see that what's happened is that as we've got our hotspot, we've got material rising up through the crust and creating more crust at these mid-ocean ridges, and that's pushing the crusts, the two types of crust, the two types of plates apart from one another. And this is what divergent plate boundaries are. The reverse of that is convergent boundaries, and at convergent boundaries we have two plates coming together, so rather than separating, they meet. This produces a number of different types of phenomena. Once again, we can get volcanic activity. We also can experience some earthquake and other tectonic activity, as well as this phenomena that we have talked about as well called subduction zones, and I'll talk about those in a little more detail in a moment. We've also mentioned, particularly where India linked in with Asia, the fold mountains. So two pieces of continental crust bashing into each other, neither more or less dense than the other, and so they literally just compress into each other, create these fold mountains, which is what has created the Himalayas. Whichever types of crusts are meeting, that will determine what happens as a result, what type of geological formations and activity we get as a result. So we do need to understand which types of crusts are coming together, whether it's continent-continent, ocean-ocean, or continent-ocean. And so that's, each of these is a type of destructive boundary, but the structures and the tectonic phenomena we get are very highly correlated to the type of collision boundary or convergent boundary that we see. So let's have a look at a couple of these in a bit of detail. So here's three examples. One where we have oceanic crust meeting continental crust, one where we have oceanic crust and oceanic crust, and another one where we've kind of got continent and continent, and so hopefully you can kind of see a little bit of difference between each of these. So the first one that we're looking at is ocean-ocean. So you can see what happens here. The continent is further back on this one. So when two pieces of oceanic crust meet one another, obviously there may be some minor differences in the density of them, but generally speaking, what tends to happen is that you have some parts of the lithosphere moving down underneath other parts. Now what happens is whenever we get these movement of one plate moving underneath another plate, we have this phenomenon known as subduction. Think about subduction the same way we think about submarines. It's when they go under. So subduction occurs. When this happens, of course, there's a whole heap of friction, and friction will generate heat, and sufficient heat will actually melt the rocks. And what it can do is then create a hot spot where that heated material, that heated fluid material will rise, and so you get volcanic activity associated with this. In fact, we see island arcs as a particular phenomenon associated with ocean-ocean convergent boundaries. The continental crust is far enough away so that it doesn't really affect what's going on at this type of convergent boundary, and we see the phenomena more associated just with that rubbing together of the two plates as one sort of slips in underneath the other one. A similar sort of thing happens when oceanic crust meets continental crust, but we do know that the continental crust is less dense. So in this case, it will kind of float above the oceanic crust, which will start to move down. Again, we'll have a subduction zone. And that subduction zone often is associated with a deep ocean trench. So very, very deep parts of the ocean where this crust is sort of dipping down underneath the continental crust. Beyond the trench, again, you find volcanic activity. The Andes are a really good example of this type of volcanic activity associated with a subduction zone and some deep ocean trenches. So you can see the explanation that we gave for volcanic activity for ocean-ocean convergence also applies to ocean-continent convergence. Except this time it's not islands that are being built in the ocean. These volcanoes are actually building mountain chains on the continent. So again, sitting above those subduction zones where all this friction is occurring and the material is being heated, and it's going to rise back up to the surface. The third example is the one that we've also looked at before, which is the formation of the Himalayas. And that is, for example, where India meets Asia. Two pieces of continental crust converging on one another. There's not so much the emphasis here on subduction as the fact that a lot of what is happening is just these two pieces of crust are actually starting to fold into each other. So you get very high mountain ranges as a consequence of this, and that's the explanation that we have for how high the Himalayan mountain ranges are. So you can see the types of geological structures are consistent for each of these types of boundaries. Their origin is slightly different, and as a result of that, whilst we get mountains occurring in each of these areas, we tend to get more volcanic activity associated with oceanic crust, and especially the formation of island arcs where you get ocean and ocean crust both meeting one another. The final type of plate boundary is a conservative boundary. This is where the plates are actually sliding past one another. So you don't have convergence or divergence, you just have them moving past one another. So we don't create new crust, but we also don't destroy much of the crust either. A little bit of time there may be a little grinding between the two adjacent plates, so there may be a little bit of destruction there, but not too much. But there is often associated with it some tectonic activity in the form of earthquakes. And certainly San Andreas in California in the US, which is probably a famous area for earthquake activity, is sitting where two plates are rubbing past one another. The problem with this is that depending on how fast the plates are moving, this can be a very slow process, and often there's long periods where nothing much seems to happen, and then you get a particular moment where something slips or jumps, and that's where that's where the origin of earthquakes can occur. Often transform faults are associated with this, so you get cracking, you get sometimes you get folding, but you also get cracking. So the difference between a fault and a fold is actual crack in the rock. So you're usually looking at something which, for example, was sitting at the same level, and now after a a fault has actually cracked, and so a certain amount of the surface has dropped a little. This is a fault. A fold is literally what it sounds like when the rocks just start to change their shape, to roll and buckle a little bit as a result of the pressure that's associated with two plates coming together. So as I mentioned, one probably best example of the conservative boundary is that situation with the San Andreas Fault. Now there's a lot of geology associated with that, but for us we can just concentrate on the fact that two plates moving side by side in different directions actually are creating some geological instability in that region, and that manifests itself as what we might call periods of quiet broken by earthquake activity. Notice we don't have the same fold mountains, we don't have the same volcanic activity that we notice for both constructive and destructive plate boundaries. We have a lot more earthquake activity associated with these types of boundaries. That's not to say that you wouldn't find earthquake activity in other regions, nor that you wouldn't find volcanic activity occurring at regions other than plate boundaries. But we need to look at each of those in a little bit more specific detail to understand them, and we will certainly do that in future videos. Thanks very much for watching.